All right, let's look at the last one. F of x is equal to 1 over the square root of 1 plus x. First thing I need to do is rewrite it with a rational exponent. And then I need to get it out of the denominator, so that's really 1 plus x to the negative 1/2. So I already had the plus sign and already had the 1. I know that my x here is going to equal x, and my k is negative 1/2. Let's go ahead and build this binomial series. So 1 over the square root of 1 plus x is going to equal 1, and then times x to the 0 all over 0 factorial plus k times x raised to the first all over 1 factorial plus k times k minus 1, negative 1/2 minus 1 is a negative 3/2, and then times x squared all over 2 factorial, and then plus k times k minus 1 times k minus 2, so negative 1/2 minus 2 is a negative 5/2, and then x cubed all over 3 factorial, and then our last one here, k times k minus 1 times k minus 2 times k minus 3 times x raised to the 4th all over 4 factorial, and then plus dot dot dot. Now let's build the series from this. Now the series from this, I can tell you, we're going to start building it and it's not going to work, and we're going to have to take a term out. So let's make sure that we're understanding what's happening here as we go along. So I'm going to start pretending that I'm building it, and then I'm going to have to stop building it because it's not going to work this way. So we're going to try it starting with the sum from n equals 0 to infinity. And we notice right away that we have a n factorial in the denominator, so we're going to go ahead and write that. And then we notice that we are alternating again because this is positive, negative, positive, negative, positive. So I'm alternating between positive, negative, positive, negative, positive terms, and we know that that's a negative 1 to the n. And then if we were to move this down a little bit and then look at what's left over, we notice that what we have left over is a 1 times x to the 0, and then a 1/2 times x to the first, a 1/2 times 3/2 times x squared, 1/2, 3/2, 5/2, x cubed, and then finally 1/2, 3/2, 5/2, 7/2, and then an x to the 4th. When n is 0, I have x to the 0, n is 1, x to the first, n is 2, x squared, n is 3, x cubed, n is 4, x to the 4th. So that's definitely an x to the n. And then I look here and I have, well, when I'm 1, I have 1 2 in the bottom. When I'm 2, I have 2 2's in the bottom. When I'm 3, I have 3 2's in the bottom. When I'm 4, I have 4 2's in the bottom. So it looks like I have a 2 to the n in the bottom there too. But then I have these other numbers left over. Well, what are those other numbers? I'm going to write them in red. All I'm left with here is a 1. Here also a 1. Here a 1 times 3. Here a 1 times 3 times 5. Here a 1 times 3 times 5 times 7. Well, what I'm doing there is I'm multiplying odd numbers. The only problem is that this first term doesn't really follow the pattern, because if you look at everything other than that first term, I'm multiplying 1 and then 1 times 3 and then 1 times 3 times 5 and then 1 times 3 times 5 times 7. So I'm increasing, multiplying by one odd number starting after n equal 1. So what we're going to have to do, because this doesn't follow a pattern, is take this term and take it out. So what is this term? If I have 1 times x to the 0, that's going to be a 1 times 1 over 0 factorial, which is 1. So that term is 1 itself, because 1 times 1 over 1 is 1. So I know that my first term is just 1. And then I'm going to add it to. Since I took out that first term, my counter now starts at 1 instead of starting at 0. The nice thing is that everything I found in my formula still holds true. It's still a negative 1 to the n. It's still an x to the n. Leave some space in between those. It's still a 2 to the n, and it's still an n factorial. What I need to figure out is how I'm going to deal with those purple highlighted numbers. I'm going to write them down over here again. Notice it's going to be a 1, and then a 1 times 3, and then a 1 times 3 times 5, and a 1 times 3 times 5 times 7. So I'm multiplying odd numbers. Well, what you do when you're multiplying odd numbers like this is you write your formula as 1 times 3 times 5 times dot 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 times the formula for an odd number, and in this case we're using 2n minus 1. And the reason we're using 2n minus 1 and not 2n plus 1, think the formula 2n minus 1, when n is equal to 1, what's that number? Well, that's going to be 2 times 1 minus 1, or 1. So we need the first time around to just be a 1. So I can't use 2n plus 1 because that starts me at 3. I'd have to use a 2n minus 1 because my counter started at 1. So this is the series for the function 1 over the square root of 1 plus x. Now, in WebAssign, they tell you that if you have this formula, this 1 times 3 times 5 times dot 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 times 2n minus 1, WebAssign is going to tell you to enter in 2n factorial divided by 2 to the n times n factorial. So if I were to put this into WebAssign, what I would write is 1 plus the sum from n equal 1 to infinity, and then negative 1 to the n would stay, and then this x to the n would also stay, and then all this stuff here, 2 to the n factorial will stay. But then I have to add this formula here. So in addition, I'd have to write times 2n factorial times 2 to the n times n factorial. So you're going to have to write that in addition if you're in WebAssign and need to write a 1 times 3 times 5 times dot 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 times 2n minus 1. That's it for Taylor and Maclaurin series.